We're given the value of a vintage car in terms of the time at which it was first valued, and it's an exponential equation. We're then told that the value was 32,000 on the 1st of January 2005. So I can substitute in 32,000 equals AP. Now, this is going to be 4 years after. Okay, t equals 0 would be 2001, t equals 1 would be 2002. It's going to be t equals 4, so AP to the 4. And then 50,000, 2012, that's going to be when t is 11. Okay, so find p to 4 decimal places. We've got these simultaneous equations to solve. So when you first learn about simultaneous equations, normally the ones where you're adding things together and you subtract them. Here we're multiplying things together. So we do the opposite. We divide. We can do the bottom one divided by the top one, because then we'll get 50,000 divided by 32,000 will equal AP to the 11 divided by AP to the 4. This is perfect. The A's cancel. We're left with P to the power of 7. So P to the power of 7 is 25 over 16. Now I need to take the 7th root, actually. Can't really avoid it. We're going to get a decimal, but that's okay. 7th root, so there's a little button here where you can put the number 7 in, and then answer 1.06583. And then to 4 decimal places, 1.0658. Show that A is approximately 24,800. I can just sub back into either one. A will equal 32,000 divided by 1.0658. Now, I wouldn't use the rounded one. I would actually use, well, the answer button, just so we don't lose any accuracy. Then I'm dividing by that to the power of 4. 24796.8, which is approximately 24,800. Great. So we've got the model. I'm just going to actually write it down. V is equal to 2, 4, and do you know what? I'm going to not round it. I'm going to write it like that, and then times 1.06583 to the t. Yeah, that's the fully non-rounded version. Well, not non-rounded. I have rounded it, but a lot later on. So now with reference, interpret the value of the constant a, that 24,800. Well, what this is going to be is we get v equals a when t is 0. So a is the value of the car. I could say in the initial time, but why not just say on the 1st of Jan 2001? And then p, that's a little bit trickier. So it's the multiplier, that 1.0658, and actually there's a 6.583% increase every year. But probably the best thing to say is that p is the factor. It's not a scale factor, but factor that the value is multiplied by each year. Maybe I could even call it the multiplier. I mean, that's what I always do when I do percentages. Just to be extra safe, I probably would write down that it's going to be a 6.6% increase each year. Finally, use the model to find the year during which the value of the car first exceeds 100,000. So let's set that 2, 4, and again, non-rounded version. You probably get away with it in A level, but best practice in science, non-rounded version. And I could say it's greater than 100,000, but let's just set it equal to 100,000, a bit easier to solve the equation. And then whatever time we get, it's going to be a little bit after that. So this is going to be, we're going to need to take logs in a second. I'm going to divide through by that 24,000. Gives me 4.03277. And the quickest way to do this is to just realize that we can turn our exponential into a log. It's going to actually be t is log of 1.06583 of 4.0. It's absolutely fine to take that log. Which gets us 21.872. So actually, this is before the end of the 22nd year. So it's before 2023, which means it's going to be during 2022. And that is our answer. Just very quickly, if you weren't quite happy with how I did that last little bit, you can imagine actually taking log. Actually, let me do it down here. Taking log to base 1.06583 of both sides. Because then you would bring the power down. This would become 1, and you get exactly what I wrote before. Okay, that's a slightly safer way, potentially, if you're not happy with how quickly I did it. The alternative is just to take log the base 10. So just a good standard one to go with. Bring the t down as before, and then you just have to divide by log of 1.06583, but this time to base 10. In fact, you don't need to write the 10, that's implied. So we get t is equal to this. If you put that in your calculator, you'll again get exactly the same thing. I'm not going to do it. Just trust me that it will be the case. And then we get our answer from there. So there are three sort of different ways to think about it. Sometimes people just like to stick with base 10. Just go with that always. Okay, fine, if that helps. There are quicker ways to do it, such as the way that I did it. But as long as you find a method that works, that's the main thing.